Hello everyone, welcome to our session, and we're looking at the paper from the Modern Cape that we've been doing, and this is question 5, which is organic chemistry, and we're doing nomenclature. We're given 8 compounds from A up to H, and we have to go as per guided by the questions through each one of these structures. Now, first thing you can do is analyze what information are given. In A, you're given a structural formula, and B is a structural formula. In C, F, and G are given condensed structural formulas, which means you might have to draw the structures formulas. And then in D, E, and F, you're also given IUPAC names, which means you might have to draw the structural formulas. In 5.1.1, or in 5.1, they say write down the letters that represent an alkene and a saturated hydrocarbon. We already disqualify A and B here. Why? Because they are not an alkene and they are not a saturated hydrocarbon. Then we go to C. So which means you can start drawing the structure of C. And first things first, you're looking for an alkene. The functional group of an alkene looks like this. So C, if I can add the picture of C here. C C is having a condensed structural formula like this. So when we draw it, we start by saying there is a CH3. And a CH3 can't just be attached. When it's in bracket, it means it's attached to a certain carbon. That is also, there's two CH3s actually. So I draw them, I put them here and here. Now that CH3, those two CH3s are attached to a carbon that is attached to a hydrogen, which in the picture it is here. And that CH is also attached to a carbon bonded to a hydrogen that is bonded to a carbon bonded to a CH3 that is attached to a CH2 and attached to a CH3. So when we fill in our bonds, we find that we must check that each and every carbon has 4 bonds around it. Now if I check here, 4, this one 3, 3. Why does it have 3? If it's not indicated in the condensed structural formula, we add it here so that it has 1, 2, 3, 4 bonds, and this one has 1, 2, 3, 4 bonds. Therefore, that is the alkene we're looking for. So therefore, the answer for 5.1 will be C. We don't have to go any further. So 5.1.1 is C. Then we get to 5.1.2. 5.1.2, what does it want from us? 5.1.2 wants a saturated hydrocarbon. The D is a dibromo, so it's a haloalkane. E is a propanoic acid, so it's a carboxylic acid. And then F, we can see that its condensed structural formula has a CH3 attached to a C and a C. And if it's a C and a C, that means there's a triple bond in between them. Then it means we might have to go with the condensed structural formula of G. So which means we have to draw G. Now G starts with a CH3 or two CH3s, and if there's two CH3s, they are attached to a carbon that has hydrogen in it here. And that's attached to CH2. That's the CH2 that is attached to a carbon with a hydrogen and a methyl group. Then there's a CH2 and a CH3. A saturated hydrocarbon is the one that has single bonds only of this alkene nature type. So we can see here all the carbons are bonded to single bonds, and therefore the answer for 5.1.2 goes to G. Next question. In 5.2.1, write down the IUPAC name of compound B. Compound B. I'll have to redraw the structure of compound B so we can do the IUPAC name. 5.2.1, we have a C double bond O with an H and a C H2 attached to a C with an H that has a methyl, ethyl, not methyl, and it has a CH. Such that if we are looking for the longest chain here, we start here 1, 2, 3, 4, 5. Now 5 stands for pent. This functional group is for the aldehyde. They end with al. You're already having a point for writing pentanol. And if we look at this chain around here, this is the side chain, and the side chain is a methyl found in position 3. So it's 3-methyl pentanol. Then we go to 5.2.2. In 5.2.2, the question wants compound F. We have to go and have a look at compound F. Compound F is a condensed structural formula, so which means we can use this one here. We can use this picture here. How do I drag it and drop it? Let me just attach it here. It's 5.0. Why did I say it's 5.1.2? It's 5.2.1. That would be. Oh, I've already done 5.2.1 here. So now I'm looking for 5.2.2. I need to scroll down. 5.2.2. You have to stretch out and give it IUPAC name. First, let's attach the condensed in order to not make any minor mistakes. Okay, added the condensed, and we're looking at compound F. Compound F says the structure that it has a CH3 that's attached to a carbon. That's attached to a carbon and a carbon with H that has a ethyl group. And after that ethyl group, there's also another ethyl group. Alright, that's the condensed. We've stretched out the condensed. Then we look, does each and every carbon have 4 bonds? These two here don't have 4 bonds, so we must add these bonds here to make it a alkyl. Not alkyl, I mean, yes, it's alkane, alkenes, and alkynes, not alkyl, alkynes. Right, so for IUPAC naming, where is this functional group found? Functional group is found at carbon number 1, 2. So what is the longest chain? 3, 4, 5, 6. When I go down, it's going to say 5 and 6. So which means here, the substituent is here. The functional group is here, carbon 2. So we start with the longest chain. Long chain, hex, in carbon number 2, YNE. Side chain, it's ethyl. Where is it found? It's found in the 4th carbon. So it's a 4-ethyl hex 2YN. Or you can say it's a 4-ethyl 2-hexyne. That's 5.2.2. Then 5.2.3, question is asking us to write down the structural formula of compound D. compound D. Compound D is a 1.2 dibromo 3-methyl butane. 1.2 dibromo 3-methyl butane. Okay, I can still do it here. Compound D is 5.3.1. The longest chain there, or the parent chain, is butane. So we're looking for C, 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 and C. It's a butane, so it must have all 4 bonds. Then in carbon number 1 and 2, there is bromine and bromine, and in carbon number 3, there is a methyl group. So we put that methyl group. Then the rest is just adding hydrogens, 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 and throughout. When you check, all carbons have 4 bonds. Then you have the structural formula of compound D. 5.32 one's compound H. 5.32 and 5.3.2. We are looking for compound H, which is 4-methyl pentan 2O. Now pent means 1, 2, 3, 4, 5. And the 2O is for a ketone, which means it has this functional group. Then the rest, so which means we fill up with the bonds because nothing has been said about them. This is carbon number 1, 2, 3, and at carbon number 4, there is a methyl group. So this is the methyl group, and you fill in the H's, the H's, 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 and H and H. Question 5.4, scroll back a bit. Compound A and compound E are heated in the presence of a few drops of concentrated sulfuric acid. Write down the type of the reaction. All right, compound A. Compound A is the structural formula we saw there with how many? Let's see, with 2 carbons in it, so it's 5.4. We're analyzing. There's 2 carbons. There's an OH. This H is H, H, H. Then compound E is propanoic acid. Propanoic acid means this is a carboxylic acid with 3 carbons in it. Now, that means we have to react these two under the presence of sulfuric acid, H2SO4. Now, under sulfuric acid, these two react in a form of reaction called what? Esterification. Esterification. All right, 5.4.2. 5.4.2 is asking us write down the structural formula of the compound that is formed. Right. They don't want of the organic compound because you get 2 products. So when these 2 react, I've always highlighted that we're going to remove H from here and OH from here. And then the bond that was at O is going to come and bond here, so that our product or final product is going to look like this. Starting from left, we'll have the H, C, C, and C, C, then the O, which is this O. The O will now attach to this C double bond O, and then it's a CH, and the CH, and CH3. And there we have our ester. They did not ask of the ester's name, but if you have to name this one, this is a ethyl propanoate. The ethyl group comes from the side that's coming from the alcohol, and the OH group comes from this side. Okay, thank you for watching and stay tuned for more videos.